For lesson 2.3 sinusoids, we are looking at phase shifts and vertical shifts. First, let's review what we talked about in lesson 2.2. If we are multiplying by a number in front of the sine or the cosine, this a number, then that is going to affect your amplitude. If we are multiplying theta by a number, which would be this b number, this is going to affect the period or the cycle of the function. Some general definitions leading into what we're doing. Translation is a shift in the graph. It could be up, down, left, right. It could be a rotation. An argument is the input of the function. So here b theta is your input. Here b theta is your input. So looking at, and then phase displacement is horizontal shift left or right. So whenever you have something affecting theta inside the parentheses, this is going to be your phase displacement and is going to shift your graph left and right. Just like what we saw in the last example or the last lesson, when there is a number being multiplied, we do the opposite of it. We would divide by it. So whenever you have a number being added, you do the opposite. You would subtract it. And this 30 is affecting theta. So that means it's affecting your theta values. If I make a table, so let's start with our normal theta values, 0, 90, 180, 270, 360. This plus 30, we're going to do the opposite. So we're going to subtract 30 to all those theta values. So negative 30, 60, 150, 240, and 330. Cosine, there's no numbers in front, so those cosine values are the same as they always are. 1, 0, negative 1, 0, 1. So when we graph this, the x values or the theta values are these that have been shifted left 30, and then the y values are the normal cosine values. So let's go ahead and plot those points on the graph. We're going to start at negative 30, then 60, then 150, then 240, and then 330. Your y values are going to go up 1, down 1. So at negative 30, we have a point at 1, 60 is at 0, 150 is at negative 1, 240 is at 0, 330 is up at 1. And make a smooth curve through those points. And this is your cosine graph. In example 2, go ahead and try that. You're going to have a vertical shift to the right 60. Go ahead, see if you can make a table and sketch that graph, pause the video, and then come back to check our answers. So what you should have done is you have your normal theta values in the first column, which would be 0, 90, 180, 270, 360, and we are going to add 60 to each of these. So here we're shifting it right 60. We're adding 60 to all those values. And so this is the column you would graph on your x-axis. And then your sine values, there's no number in front of the sine, so this is the column you would graph on your y-axis. So when we plot those points, 60 should be at 0, 150 is at 1, 240 is at 0, 330 is at negative 1, 420 is at 0. So make a smooth curve out of those points. And that is your sine wave, shifted right 60 units. Vertical displacement is a shift up and down in the graph. And you're going to see that when you're adding or subtracting a number outside of the trig function, so it's not touching theta at all. It's off to the side, usually in front. So if we're going to add 2, that means I'm going to change all my y values and increase them each by 2. So when I make my table, theta is not changing because there's no number on theta. So that's 0, 90, 180, 270, 360. Then I can put my cosine values, which would be 1, 0, negative 1, 0, 1. And we are adding 2 to each of these cosine values. So that would be 3, 2, 1, 2, 3. So when I plot these on the graph, my x-axis is this first column, my y-axis is the last column. So we are going to have 0, 90, 180, 270, 360. We're going to have y value 1, 2, 3. So here's a little bit of a change. Here my x-axis is no longer the middle of my graph. So whatever your middle y value is, this is going to be your sinusoidal axis. Whatever the middle y value is your sinusoidal axis. So draw a dotted line. That's where all of your middle points are going to go. So 0 is at 3, put a point. 90 is at 2, so on the dotted line. 180 is at 1. 270 is at 2 again, back to the dotted line. 360 is at 3. So I want to know where the sinusoidal axis is so I know how to curve the graph. So it curves down, curves up, curves down. And so that is what your graph should look like. So this has been a vertical shift of 2 units up. Try example 4 on your own. So you should see this is a vertical shift of 3 down. Go ahead, make the table, make the graph, and see if our answers are the same. So here's the table I got. Theta values haven't changed, so we're going to use that first column. That column's not going to change. I put my sine values, but I took 3 from each of those. So subtracted 3 from all of my sine values, and that is the column you're going to graph on your y-axis. So I went ahead and labeled my axes. So then we're going to plot the points. So 0 is at -3. Oh, go ahead and put your sinusoidal axis at your middle y value. 90 is at -2. 180 is on the sinusoidal axis. 270 is at -4. 360 is back to your sinusoidal axis. And sketch your curve. So some general conclusions of what we've seen here is that when there's a number being added in front or subtracted in front, this is your vertical displacement. And when there is a number being subtracted or added inside the argument, then that is your phase displacement.